Hello class, welcome to Algebra Lesson 8.3, which is all about quadratic functions in standard form. By the end of this lesson, you should be able to graph quadratic functions using standard form. All right, let's look at example 1. Relate c to the graph of f of x equals ax squared plus bx plus c. So first of all, standard form is this right here. Standard form is f of x equals a times x squared plus b times x plus c. Okay? And looking at that form, you can see it's a little different than vertex form yesterday. Vertex form in our last lesson, remember we talked about how it was a times x minus h squared plus k. So you can see it looks quite a bit different, but it ends up graphing the same type of graph. It forms a quadratic, a parabola. Okay? So looking at this, what information does C provide about the graph of f of x equals ax squared plus bx plus c? So if we graph multiple functions of that form, and we look for a connection between the graphs and the value for each function. So if we look at it, you can see here are the three different functions that have been graphed. And notice that they highlighted our value for letter C in red to make it easier to see. All right. So in this first graph over here, we have -3 is our C value. And notice that the parabola crosses the y-axis at -3. Okay, the next one, in the middle, we have -1, and it crosses the y-axis at -1. In our last graph, you can see we have C is a +1. It crosses the y-axis at a +1. Okay, so whatever C is, that tells you what your y-intercept is for the graph. Now, a common error I'll see students make is they'll assume that wherever it crosses the y-axis is also its vertex, which is not true. As you can see by all of these graphs, the place that it crosses the y-axis is not the vertex on any of them. Can it sometimes be the vertex? Yes, but it does not always have to be the vertex. And remember, our vertex is the kind of turning point of our parabola, either the highest point or the lowest point on our parabola. Okay, so remember, C tells you where it crosses the y-axis. All right, here are a couple of key things for you to know about the standard form of a quadratic function. Okay, so we have ax squared plus bx plus c. In this form, a cannot be 0, because if a is 0, that means that that goes away, right? And we're left with bx plus c, which is just our slope-intercept form. Okay, so it's very important. A cannot equal 0. A can equal 1 and just look like an x squared, but a can never be 0, okay? Then the value of c is the y-intercept. That's what we just looked at on the last page. And then we have the axis of symmetry. So back in 8.1, we talked about how the axis of symmetry, we were looking at parabolas that did not move from the origin. We looked at parabolas that always looked either like this, or we looked at parabolas that looked like this, where the vertex was always at the origin, and therefore our axis of symmetry was always 0. Now we're going to be moving our parabola around, and we're going to use different form. We're not using vertex form. Vertex form is really nice because it gives you the vertex, hence its name. Standard form, less obvious. So there's a process that you have to do in order to find the axis of symmetry. And the way that we find the axis of symmetry is we use this formula right here. X equals, so I'm going to write axis of symmetry. I highly recommend writing this down and having it somewhere while you work on your assignment. This is something you need to memorize before our test. Okay, but the axis of symmetry is x equals -b over 2a. If people remember that formula, they do just fine. However, if there's something they ever forget about this formula, it's the fact that there's that negative right there. So please be sure to pay close attention to that negative. And this axis of symmetry, that x value that you solve for right there, that tells you what the x value is for your vertex, okay? So the axis of symmetry is super useful. You just have to remember how to find it. Now let's practice graphing this type of problem. When you're graphing from standard form, before you even graph, you have to solve and find your axis of symmetry. You have to find your axis of symmetry because you need that x value in order to plug in to find the vertex. Then once you have the vertex, you can use the y-intercept that I showed you. And then parabolas are symmetric, so you can reflect things over the axis of symmetry. That's another great reason to find the axis of symmetry. Okay, so let's walk through this. I'm actually going to try to make this a little easier for you. I'm going to add a shade just to help you understand exactly what I'm looking at step by step. Okay, so before we even get to step one, let's read our question. Graph f of x equals 2x squared plus 4x plus 3. What are the axis of symmetry, the vertex, and y-intercept of this function? And after I walk you through this problem, you're going to try finding those three things on your own. So make sure you're paying close attention, okay? All right, so the first step, you find your axis of symmetry. So x equals negative b over 2a. And if we look at our function, sometimes I like to just go through before I start solving things and write down what a, b, and c are. A is whatever values with your x squared. In this case, it's a 2. B is whatever values with your x. In this case, positive 4. And c is 3, a positive 3. Okay, so then I plug that in. I have negative 4 over 2 times 2. 2 times 2 is 4. So I have 4 over 4, which is just 1. And then I have that negative sign. So my axis of symmetry is x equals negative 1. It's really important when you're writing an axis of symmetry to write it as an equation like that, right? X equals. Don't just write down negative 1. All right, now that we know what the axis of symmetry is, we can use that to find our vertex. So what I'm going to do is I'm going to replace x with a negative 1. So then I have 2 times a negative 1 squared plus 4 times a negative 1 plus 3. Negative 1 squared is a positive 1. So 2 times 1 is 2. And then 4 times negative 1 is negative 4. So I have 2 minus 4. That's negative 2. Negative 2 plus 3 is a positive 1. So my vertex is going to be negative 1, 1. Okay, so step 1, axis of symmetry. Step 2, plug your axis of symmetry value in to get your vertex. All right, so now I know my vertex, so I can plot my vertex. And then what I can do is on a graph, once I've plotted that point, negative 1, 1, I can plot the y-intercept, our c value, right? So in this case, 3. So that means it crosses the y-axis at 3. And then I can plot its reflection. And if I want, I can try plotting another point. Usually, I encourage people when they're starting to plot quadratic functions for the first time, start with 5 points. Okay, start with 5. I know that seems like a lot, but after some practice, you'll be able to cut that down. You can usually do 3 and know what it should look like. 3 is the absolute minimum, and often if students aren't fully comfortable and they only do 3, they end up getting things wrong. So I encourage 5, but 3 is the minimum, okay? So you can find another point and then just plot its reflection. So you can see, sorry for this annoying blue line. I'm actually going to just move this down so that way it's, there we go. You can see we have the vertex at negative 1, 1, plotted the point at 0, 3. My axis of symmetry is this line right here, that x equals -1. So my y-intercept right here is 1 unit right of my axis of symmetry. So I know I have a point 1 unit to the left of the axis of symmetry. And then if I were to plug 1 in, I would get 9 out. And I see that's 2 units from my axis of symmetry. So I'm going to go 2 in the other direction, plot a point, and graph. So you can see that by doing that, I only really had to solve for 3 points, and then I just used the symmetry to find 2 more. So doing 5 points, really not that big of a deal. Okay. It is now your turn. Here is your function. I want you to determine what is the y-intercept. Write it as an ordered pair. Good luck. All right, for this problem, hopefully you realize that your C value is 4. Therefore, the ordered pair would be 0, 4. All right, now I want you to find the axis of symmetry. Make sure to write your answer as an equation. Good luck. All right, for this problem, hopefully the axis of symmetry you got was x equals a -1. If not, please be sure to check my work, and please be sure to ask questions if you need help. Last part, use that axis of symmetry to determine the vertex. Good luck. Okay, for this problem, hopefully you ended up at a -1, 3 for your vertex. If not, be sure to check my work and be sure to reach out for some help. I am happy to help you. All right, the last example for today. We have comparing the properties of 2 different quadratic functions. We have the trajectory of the water from fountain A, so that's the path the water takes, is represented by a function in standard form, while the trajectory of the water from fountain B is represented by a table of values. Compare the vertex for each function. Which trajectory reaches a greater height in feet? Okay, so we have fountain A. You can see it forms a parabola that can be represented by x squared plus 2x plus 8. And if I want to figure out how high it is, that means I have to determine what is the vertex of that function. So I'm going to say, let's solve for the axis of symmetry first. So my A value is a -1. My B value is 2. So x equals negative and then B over 2 times A. So that becomes -2 over -2, or just a 1. Okay, so I have a 1 for the vertex, for the x value. Then if I plug that in, I have f of 1 equals -1 squared plus 2 times 1 plus 8. So that's -1 plus 2 plus 8. So I have -1 plus 2 is 1 plus 8 is 9. Okay, so fountain A reaches a height of 9 feet. Okay, let's figure out fountain B. Looking at a graph. Remember, parabolas are symmetric. So I'm looking for numbers to kind of mirror each other. If I look, I have a 5 and a 5. I have an 8 and an 8. So that tells me that my vertex is going to be this point right here, -4, 10. So that means that my height of this fountain is 10 feet. So that means that fountain B reaches a higher height. All right. And that is everything I have for you today. So make sure you write down all of that information, how to find the y-intercept, axis of symmetry, how to determine the vertex, and then also make sure you start memorizing that. Okay? This is a good screenshot to kind of help you summarize how to graph, but make sure you know all of those processes. If you have any questions, please be sure to reach out for some help. I am happy to help you. Have a great day.